Hello there. Let's talk about the Coulomb. If you've ever found that term a bit confusing, don't worry, you're not alone. This short guide is designed to make the whole concept really clear and simple, and to show you how it's useful in your day-to-day work. So here's how we're going to break it down. We'll start with a quick refresher on electric current, something you already know. Then we'll look at why we have a bit of a counting problem. After that, we'll introduce the Coulomb itself, look at the formula that uses it, and then we'll finish up with a practical example to see it in action.
Okay, so let's begin with a concept you're already familiar with, electric current. Making sure we're solid on this first gives us a really strong foundation for understanding the Coulomb.
At its most basic, electric current is just the movement of electrons. In a simple circuit, like the one you see here, electrons flow from the source, they go through a load, like this lamp, and then they travel back to the source again. The key idea here is that it's a continuous, steady flow. And of course, we need a way to measure the rate of this flow. How many electrons are moving past a point at any given time. And as you know, the unit we use for that is the ampere, or amp for short. Right, but this leads us to a bit of a practical problem. If current is all about the flow of electrons, then how many electrons are we actually talking about when we measure 1 amp of current? Just think about that for a second. If you have a 1 amp current flowing through a wire, imagine trying to count how many individual electrons move past a specific point in just 1 second. Any guesses? Well, the answer is this enormous number. It's over 6 quintillion electrons every single second. As you can probably guess, trying to work with numbers that big or to count individual electrons is just completely impractical. So we clearly need a better, more convenient way to measure them. And this brings us to the solution, the Coulomb. It's the practical answer to this problem of dealing with massive numbers of electrons. So let's look at the official definition. A Coulomb is the quantity of electricity that passes a point when a current of 1 ampere flows for 1 second. The most important thing to remember is the difference here. An ampere is a rate of flow, but a Coulomb is a specific amount of electricity. Here's a simple way to think about it. Instead of counting those billions and billions of individual electrons, we just group them together into a huge, standard-size packet. And one of these packets is what we call a Coulomb. It's just a much more manageable way to talk about a quantity of charge. So now we've got these 3 ideas, the quantity of charge in coulombs, the rate of flow in amps, and of course time. And luckily for us, there's a very simple formula that connects them all. The formula is simply Q equals I times T. In this relationship, Q stands for the quantity of charge, I is the current, and T is the time. This is one of those fundamental formulas you'll use again and again. Let's just look at each part. Q is the quantity of charge, and it's measured in coulombs. I is the current, which is measured in amps, and T is the time. Now, this next part is really important. Time must always be in seconds for this formula to work. So if you ever get a problem with minutes or hours, your first job is to convert it to seconds. You know, the best way to really understand a formula is to actually use it. So let's walk through a practical example together and see how it all works. Okay, here's our problem. We've got a current of 8.5 amps, and it's flowing for 3 minutes. The question is, what is the total quantity of electricity, or charge, that's been transferred in that time? Let's solve this step by step. First, we identify our formula, which is Q equals I times T. Second, we list the values we know. I is 8.5 amps, and T is 3 minutes. Step 3 is that crucial conversion. We need to get the time into seconds. So, 3 minutes multiplied by 60 gives us 180 seconds. And finally, step 4, we calculate the answer. We just multiply the current by the time in seconds. So that's 8.5 multiplied by 180. And that calculation gives us our final answer, 1530. And because the unit for quantity of charge is the Coulomb, the total charge transferred is 1530 coulombs. Simple as that. So let's just do a quick summary. We started with electric current, which is the flow of electrons. We know the ampere measures the rate of that flow. We saw that counting individual electrons isn't practical, which is why we have the Coulomb. It's a unit for a specific quantity of electrons. And finally, we use the formula Q equals I times T to connect all these ideas together. The key takeaway here is that understanding the Coulomb gives you a real-world way to measure a specific amount of electricity. So, here's a final thought for you. Now that you can calculate charge, think about how this idea might connect to other things you know, like the relationship between voltage, current, and resistance in Ohm's law. It's all connected, so keep exploring.